In my presentation today, I'm going to share with you my journey through BIM, how I ended up in Kuching in 2024. This is my first time in Kuching, so I have not actually seen any of Kuching yet, so this afternoon I hope to see some of the city. So a very big thank you for the warm welcome. And my presentation is going to focus on the problem. And the problem can be a number of things. The problem can be a requirement for training. The problem can be a lack of understanding. For me, the problem around BIM is training, education and knowledge sharing. So today is a great opportunity for me to share with you some of my experience and frame the conversation around BIM, around what is the problem. Now my Malay is not very good, so if I mispronounce this throughout the presentation, please forgive me. But my understanding is that it's apa masalahnya. Okay, that's not too bad, that's not too bad. So that's the only thing I want you to remember from this presentation. So for the next hour, all I want you to remember is apa masalahnya. That's all you got to remember. So let's talk about the presentation. They've given me an hour and a half, so you're going to have to put up with me for an hour and a half. I will do my best to slow down and speak clearly so you all understand. But I'm going to speak about three major topics. The first topic is around BIM and getting the basics of BIM correct. What is BIM? What does it look like? What does good BIM look like? What's the value of that process? I'm then going to talk to you about reality capture and how cameras have transformed construction management. How many people here took a photograph of their MACC in the last week? Who's taken photographs of their MACC? Now be honest, come on, be honest. Right? How many people have taken photographs of their construction projects? Right? We take photographs of our MACC more often than we take photographs of our projects. So I want to encourage you to take more photographs. And I'm going to leave you with some glimpses into the future of technology in construction. It's not happening on every project, it's only happening on a few, but it's very, very exciting, and it's worth knowing what's coming down the road. Maybe we'll see them on some projects in Kuching, maybe we'll see them on other projects in Sarawak, but these technologies are coming, and I'm going to give you a glimpse of some of them. So those are the three topics we're going to go through today. So my presentation today is going to follow a timeline. And as I was introduced, you heard some of those snippets. I'm going to tell you about my journey from when I graduated a long, long time ago in a land far, far away in 96, all the way up to present day. So I started my career working as an engineer, working for a company called Arab, who some of you may know. And I was working on projects in Ireland in the late 90s, doing 3D modelling. So I was doing 3D modelling of steel structures back in 98, 99. So I've been doing 3D for a long time. In 2000, I moved to Hong Kong. It was my first experience of living in Asia. And in 2003, I started my first company. So within a couple of years of moving to Hong Kong, I really liked Hong Kong, but I wanted to try creating a new company. And that company was focused on using 3D technology to improve construction projects, try and reduce risk, reduce costs, and improve schedule keeping. The mission has not changed in 20 years. My mission remains the same. I want you to start thinking about how to use 3D modeling to save costs, save time, and reduce risk. This was my first BIM project in Hong Kong. This was an office building, and we were modeling ductwork and pipework. And this was a very simple 3D model. So for those of you who are thinking, well, BIM is new, I have a bad news. This technology is 20 years old already, and I've got the grey hair to prove it. So between 2003 and 2007, as the company was growing, we started working on a number of different projects, but all of our projects were taking 2D drawings from somebody else, making a model, and then finding a problem in those models. And over that period of time, that 4 or 5 years, it was very obvious that it was a valuable process, but it was not effective. Because we would find a problem, and then a month later we would go back to the architect, and they said, oh no, we fixed that problem already. So you would never actually change the design, you never improve the design. So the first real BIM project that I got involved with, actually before I get to the BIM project, the reason I live in Malaysia is I met my wife playing golf in Malaysia. My wife is from Ipoh, She's a squash player and now a pickleball player. But the reason I live in Malaysia is all down to my wife. And she dragged me back here a couple of years ago. So you can thank my wife for bringing me to Malaysia. Yes, a round of applause, of course. So I'm going to speak about the first real BIM project which we did was back in 2007. This is an industrial facility in Hong Kong. It's the Cathay Pacific Cargo Terminal. This is a very, very large, very, very complicated industrial building. And the owner set out to solve a couple of problems. And the owner, his Masalahnya, was basically he wanted to reduce the risk of problems on the site. He knew the building was complex. He knew that he could use models to solve some of the coordination issues. There was one very straightforward objective. Use the models to produce the construction drawings. That was the objective. Because that would then drive everything else. So, show you just what this looks like. 2007, this was Revit. This was a very early version of Revit. Revit is the most common tool for doing BIM. There's a structural model, and the structural model had a number of elements or properties to it, so we could determine the different types of objects, columns, beams, etc. We had an architectural model. This was an industrial facility, so there wasn't much architecture, so my architectural friends here will be like, well, this is not an architectural project. And then we had all the building systems, the mechanical systems, the electrical systems, and the coordination. And then we had to do the coordination. This was a very complicated project, and it taught us some very valuable lessons. The first one is you have to put a lot of information into the model. So building the model is not the actual end game. It's all the information inside of the model. So understanding what fans you have, understanding what pumps you have, understanding what cable trays you have, that's all information in the model. So you need to understand that it's building up the information that's as valuable as building up the 3D modeling. One of the problems with this project was coordination, and I'm going to come back to that in a second. But this is just one example of the level of piping in the building. And then we use that to produce the drawings. So these are drawings from 2007. And you can see the early stages of an understanding of how to use the technology differently. If you look at a CAD drawing on a computer screen, it will have lots and lots of color. But then when they print out the drawing, it's all black and white. But it's 2024, we have such thing as color printers. So why don't we have colored drawings? And if we have colored drawings, they become easier to understand because you can see different systems and different layouts. So these were the drawings in 2007. The technology exists. It takes a configuration, it takes a process. But then you can use it to produce good quality documentation. And just to show you, these are drawings from the metro in KL. These are MRT2 drawings. So the level of detail and the process is more sophisticated. The quality of the drawings is much, much better now. But again, it includes color. And you can see the different layouts without getting into the detail. This is a mechanical system. You can schedule out all the information. All of this can be done automatically. But the best part of this is that because you've used a 3D process, you can produce multiple sections and you can produce 3D views. So if you're working in JKR and you're using these tools, if you want to be really successful and you want to get more people involved in the process, don't just produce a standard set of drawings. Add in these 3D views. And you will start to see two things happening. First of all, people will realize, oh, hang on, somebody has built a 3D model of this project. So if you're the engineer working on the construction project, you will be able to go, hang on, I know there's a 3D model. I've seen 3D pictures on the drawings. There must be a 3D model. And then what will happen is more people go, hey, how did you make those 3D models? I want to use those 3D models. So please, 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 if you're working in the design, whether on the architectural design, the engineering design, and you are using any kind of 3D modeling, it doesn't matter what the 3D modeling is, make some isometric views and put them in the standard drawing sets. Don't just produce 2D drawings and assume that people know you're doing BIM. Make sure you put these 3D views in the drawings. So, apa masalahnya? I'll get it right before I'm finished. What's the problem with this BIM process? Because everybody says, well, BIM is expensive, BIM takes time, BIM is difficult. Why do the architects and the engineers resist BIM? What's the problem they're resisting? My understanding, having been on both sides, on the engineering side and the construction side, when you specify that you want a BIM project, you are increasing the amount of work the engineers have to do. You're increasing the amount of coordination that has to be done during the design process, and you're creating a lot more coordination work. The problem is the architects and engineers don't want to do the extra work because they don't get paid to do the work. That's the contractor's job. So the first problem that you come up with as an owner is when you start demanding BIM, the design team will start going, no, that's the contractor's problem. Okay? So just beware of this problem. And the reason is that when they start doing this coordination process, they call it clash detection. I call this chasing your tail. If the process is not correct, you keep chasing your tail. You go round and round and round in circles. So what does this look like and what causes this problem? On major projects, on complicated projects, our BIM teams will create what we call a clash matrix. We will create basically a set of checks that we want to do in the model. We will check the architecture, we will check the structure, we'll check the mechanical systems and so on and so forth. And we will check one against the other and we end up with this matrix. And every single system is checked against every other system. What that creates is hundreds and hundreds of tests. And each of those tests create hundreds and hundreds of clashes or coordination issues. So you end up with these long lists of problems. So one example, just to show you one simple snapshot. In this example, the ductwork is clashing with the concrete. Okay? Now this is why the industry does not like BIM, because it is very easy to find all these problems. It is very difficult to sort out which one's most important, which one has to get fixed first, and when do I have to get it fixed by? So, if you're just new to BIM, it sounds great. But once you've done one project, you realize this process of finding the issues and finding the coordination problems is easy. If you give me a model and you give me 1 hour, I will give you 10 problems back. If you give me a week, I'll give you 1,000 problems. It doesn't mean the design is bad. It doesn't mean that the engineering is poor. It just means that there's more work to be done before we can construct these buildings. So how do we solve this problem? What's the solution? We recommend that you put in place a coordination process that's set to a timetable. We say every 2 weeks is a guideline. This process is cyclical. It goes around, it's iterative. So every 2 weeks we repeat the process. We put the models together, we identify all the coordination issues, we run a coordination meeting, we prioritize the problems, and we assign those problems to somebody to fix. Design Management 101. So this is what it looks like in reality. This is a team of engineers reviewing a model, and they're going through the issues one by one by one. Okay, saying, okay, well, Ronan, we're going to get you to fix this one. Director, we're going to get you to fix this one. Mr. Architect, we're going to get you to fix this one. And we assign issues to different people to fix. But most importantly, we give them a deadline. And we agree on a timetable. Can you fix this next week? Can you fix this in 2 weeks' time? If it's not important, we'll fix it in 2 months' time. But we agree on a timetable to fix the issues. So we find the problem, we find someone who's going to fix it, and we give them a deadline. And then we create a process to manage that. So if you're using Navisworks, you can create a whole set of saved viewpoints in Navisworks. And if you've got things set up correctly, it can be very, very efficient. If you're using a more cloud-based system, you can use a system like BIM Collab. And the way the system operates, every issue is tagged, every person responsible is tagged, and a deadline is set up. And then you can manage that process. So as JKR, if you're project managing a design, if you're project managing the shop drawing process, if you're managing any kind of deliverable, you need to set up this BIM management process. Identify the issues, identify who's responsible, and then give them a timetable. And then manage that process. So, how do I play my role in this? With 20 years of experience, I'll be quite honest, I don't like getting involved in projects and doing clash detection and going to meetings. I much prefer to be the advisor and give people advice. So the way I play this is that through my new business at FTI, I come at this in 3 ways. So the first thing I do is I will look at how the design teams are performing against the requirements from the client. So if JKR have set out a set of requirements for a bridge project, a hospital project, a school project, I can look at what the design team are doing, and I can tell them, okay, you need to improve this, you need to improve that, you need this training, you need that training, and give the design team the support and training they require to make them successful in the project. They have to be able to meet your requirements, because when we get to the next phase of going for construction procurement, we need to know that we've got good quality models, good quality design, otherwise it's been a waste of time and a waste of money. And then the third step is actually working with the contractors to make sure that their supply chain, the mechanical contractors, the steel contractors, can also participate in this process. And giving them the training and the briefing and the support to make sure they're successful. So the way I describe this, I'm a bit like a coach to a basketball team or a coach to a football team. They play the game, they work out the players, I stand on the sidelines and give them a playbook, give them the moves for the attack, give them the moves for the defense. But I coach the teams through this BIM process. And I use my experience of doing it wrong in previous projects to make sure they don't repeat the same mistakes. So if you're setting up a project and you're new to BIM, these next 6 or 7 slides are probably a good starting point for a client who wants to understand the risks in their project with the designers. So as you set up a new project, what are the problems? Apa masalahnya? What are the problems I have to work out? So we're going to go through it discipline by discipline. This is like a cheat sheet. So the next project you're doing, you have a starting point. So the first one are our friends, the architects. Most architects in Malaysia are now using Revit. They might claim that they're not, and they might claim it's more money and everything else, but most of them have the ability to produce 3D models. This is down to a number of factors. It is down to factors like JKR, Sunway, Gamuda, and other developers like YTL demanding that the architects work in these processes. It's also down to JKR. JKR have a general policy that all their projects must be done in BIM. So you can assume that the architects are working in BIM. What you need to make sure is they have the capacity and the skills to deliver the project. So usually, the architect is a safe bet. You don't really have to worry about the architect too much. The structural engineers, I started my career in 1996. We were doing 3D analysis back then. Most of the engineering firms are working in 3D already. They're doing 3D structural analysis, 3D structural detailing. What they're not used to doing is sharing those models with the architect. So what you have to do is you have to make sure that the architect and the structural engineer are sharing the information and they're checking each other's work. So the columns are in the right position, the openings in the right position, the levels are correct. But that interchange should happen automatically. In some cases, the engineers may need a bit of training, but in generally speaking, it's something that comes naturally to a structural engineer. And I come from a structural background. Same with the civil engineers. There are probably less experience in the civil engineering groups. So people that design highways, people that design bridges, those that are doing hydro projects, they have not been exposed in the same way. But if you're doing an infrastructure project, an MRT project, the hydrogen bus project, they can be trained up quite quickly. It comes again naturally. So you need to watch out and see what are they up to. I met a mechanical engineer earlier, and this is where I have to be very careful what I say next. The mechanical, electrical, and plumbing engineers struggle in the world of BIM, in the design phase. And the reason that they struggle is they're not used to doing fully detailed designs. They're used to doing schematic layouts, they're used to doing kind of level 2 design where they work out all the major routing, but they don't worry about all the interference, all the coordination. Typically, that's rest for the contractor. So a lot of the coordination is left up to the contractors to solve. That is a major problem when it comes to BIM, because we want to actually produce a coordinated design as early as possible. So this is where, as a project manager, you need to spend a bit more time and a bit more effort to make sure that the mechanical engineers, the electrical engineers, and the piping engineers are actually participating. Because if they're not, all the problems that are baked into design will become problems in the construction project. So this is the area that I urge you to pay attention to. Making sure that the engineers on the building services, mechanical design, are actually supported, they have the training they need, and they're given the time to do the work. And then once you've put all of those teams together, the biggest challenge, like I've already mentioned, the clash detection and the coordination. Most design firms operate in silos. Mechanical engineers will take the architect's 2D drawing and then draw on top of it. They don't want to worry about openings, they don't want to worry about beams, they don't want to worry about risers. So that coordination is very, very important. So managing the coordination between the structure, the building services and the architecture, that is the biggest challenge in running a BIM project. So what's the trick? How do I set myself up for success? How many people here have heard of a BIM execution plan, or a BEP? Anybody here heard the term BIM execution plan? Now you have. Oh, we've got our friends from the big project. This is the most important document that JKR must have in your contract documents. If you want to be successful, JKR have to specify and contractually obligate the contractors and designers to work in BIM, and they must specify this set of documents. The BIM execution plan. Who is going to do the work? What are their roles and responsibilities of the architect, the engineer, the designers, and the BIM staff? How are you going to collaborate? How are you going to do the coordination? What software are you going to use on your project? And that needs to be specified, because the more specification that you make at the beginning of this process, the more likelihood of success. Then you need to define what we're going to use BIM for, which problems are we going to solve, and then you can set out your standards and guidelines. The good news, all these documents exist, and JKR have a full suite of BIM execution plan documents that you can use. What I encourage you to do is put them into the contracts and make them mandatory. So that's the kind of BIM background. And everything else I'm going to show you this morning is based on that being correct. That you have got structural models, you have got engineering models. So I call that getting it right. I call it the BIM basics, so that you can do coordination, that you can do planning, and you can do the sequencing. If you're really good, you can do quantity takeoff, and you can do information management. So one of the things that's in the middle of the slide, I'm going to quickly show you, is scheduling and programming. How many projects have you seen where someone's done a 4D sequence or a construction simulation sequence? Has anybody seen a construction simulation sequence? A few people? Okay. So I'm going to share with you an example of a 4D BIM sequence, but more importantly, I'm going to tell you how to use it from a project management perspective. Most of these things are used for marketing and PR, but I want to show you how to use it for actually managing a project. So I'm going to share with you an example from a project that we did about 10 years ago. This is a stadium in North America. This is in Atlanta, Georgia. It's called the Mercedes-Benz Stadium. I'm going to show you how we planned the work. I'm going to show you what happened on the project. And I'm going to show you how we use 4D BIM to actually monitor the work. So 4D BIM is basically linking a computer model to a schedule or a program. So what you're doing is you're taking all the activities that are planned for the works and you're linking those to the actual models. So you can actually simulate the construction of a project. This works for buildings, this works for bridges, this works for underground structures. Any type of project can be sequenced. There are a number of use cases for this technology. So the first one is actually understanding a project and understanding a construction methodology. So if you're an engineer, can I build a viaduct in this sequence? And will it be viable? And once you've created a sequence, you can use that to communicate with your senior, you can use that to communicate with the contractors, and you can start to get feedback about your understanding of the project. When the project starts, you can use this for planning. You can use it for safety planning, logistics planning. More importantly, you can also use it for maintaining a progress record. So if you keep this up to date through the process, you can maintain your progress updates. And we've all been involved in projects that have ended up in disputes around time, disputes around costs. Sometimes these models can be used to demonstrate what was planned and what happened. That can be used by the owner, it can be used by the contractor, and it can also be used to demonstrate design change. What changed throughout the life of a project? So using this example of a stadium in North America, I know it's a very complicated project, but it's a good example. What is the problem? Pretend that you're the contractor and your job is to erect the steelwork for the stadium roof. And this is one of the largest stadiums in the world. How do you plan the delivery of the steelwork, the positioning of the cranes, and the erection of the steelwork to be an effective process? Traditionally, they would use 2D drawings, they would have cardboard cutouts of the cranes, and they would play with all these cardboard cutouts for hours and hours and days and days. What we did is we created a virtual simulation. So we took the stadium model, and each block that's in the ground is the preparation of the steelwork. So they have to first of all assemble the steelwork on the ground, and then they use the cranes to erect the steelwork. So the blue is the erected steelwork in the sky. So we went through 6 weeks or 8 weeks of this process, working with the planners, working with the crane operators, working with the delivery teams to make sure that we could get every single piece of steel into the stadium, we could erect all the steelwork, and that we would actually be able to do this successfully. So this is planning using a 4D sequence. So we've taken the structural steel model, the BIM model, and we've linked it to the construction schedule. And you can see we've planned out every single step of the works. So you can see how it's all going to go. The good thing with this presentation is that once you've seen the sequence, you understand how that's going to get built. And then you can share that with the steel fabricator, you can share that with the site workers, you can share that with the safety officer, you can share that with the public if you want. And you can get them to all understand, okay, this is what's going to happen. So that's what it looked like before construction. The great thing with this project is they set up a CCTV, and EarthCam recorded this project. This is what it looked like in reality. This is a time lapse. And again, I recommend this for all your projects. If you have the ability to put up a CCTV, it's a great way of recording a project. So you can see all the cranes are inside the stadium. There was no space around the stadium. All the cranes were inside the stadium. And then you will see the steelwork was erected pretty much the same way we planned. So we had a plan, and then we had the actual. And you can do a comparison between the two. And this is where 4D is very, very valuable. So most people will use the 4D to make the animation, and then they'll stop. But then you're losing out a lot of value. If you maintain this process through the construction project, you can actually monitor your progress against the planned. So here you can see on the top curve, the orange line was what was planned in terms of productivity. And then the blue is the actual, the red. The red line is the actual data coming from the project every week. So we plotted out using the sequence, and in the top, you can see the actual sequence that was being monitored. So on the top left panel is the erection of the steelwork on the ground, or the preparation, and in the top right panel is the actual erection sequence. So if you're doing this kind of sophisticated project, like a bridge project or a very complicated hospital project, this is a very good way of monitoring how we planned out the works and then what's actually happening on the site. And by doing it this way, you create a very good record of the actual project. So this is a very powerful way of recording a project as it goes forward. So the learning here is, don't just use 4D for marketing, use it for project planning. Now I'm going to transition into and speak about reality capture. So going back to our Cathay Pacific cargo project as a reference, when we were doing the construction of this project, there was a large number of problems. Let's be honest. BIM was not a big success. BIM was useful, but a lot of things happened that shouldn't have happened. One of the problems was that the mechanical systems, they were highly coordinated in the models, but they were not installed in the same way. So what you will find on projects, again, this is a problem with BIM, the BIM team will create a ductwork layout or a pipework layout, and then the guys on site will go, nah, we're going to do it differently. And then they put the pipe somewhere else. And then you have a problem. Then you have a site that's different from your engineering coordination model. And then you're in real trouble. So in order for us to monitor what was happening on the site, we would walk around the project with a camera, digital camera, take a photograph, and then we would go back to the office. We would try and find a similar location in the models, and we would do a visual comparison. So in 2009, 2010, the best technology we had was to take basically holiday photographs and compare them to the models. And if something was different, we would send an email to the construction manager going, at this grid line, this cable tray is in the wrong location on site. And then we had to make a decision. Do we have to take it down and fix it, or can we work around it? Okay, but we had no way to link what was happening on the site to what was happening in the model. So the challenge in 2009 was, there was a model that was on a computer, and then there was what was happening in the real world. And there was no way to bridge that gap. They lived in two very different worlds. So the problem is, How do I compare what's happening on the project to what's in BIM? And it was very, very difficult 10, 15 years ago. The good news is, now it's really easy. And it's also really affordable. So I want you to see what's happened in 10 years, and I guarantee you, at least 2 people are going to get on Lazada and order a 360 camera before this presentation is finished. Because this is really useful technology. So, before I tell you about that, my wife got me married in 2012. That was it, I was done. In 2014, we moved on to the Midfield Concourse Terminal. And this is where we learned about a better way of linking BIM to the site. So I'm going to speak about 3 technologies this morning. The first is going to be laser scanning. The second will be 360 cameras, and these are the sequence, and then I'm going to talk about drones. Laser scanning was the first technology available that could link the real world back to the BIM world. By scanning a construction project with laser scans, I can overlay that with a BIM and I can start doing a direct comparison. It was no longer a spot the difference visual check, it was a real 3D check. 360 cameras have become very popular in the last 3 to 4 years, mainly because the technology's got much, much better, but they're also much, much cheaper. So you will start to see many, many projects using 360 cameras. I can tell you now, all the major contractors in Malaysia are already doing this process. So Sunway Construction, Gamuda Engineering, YTL Construction, all have 360 cameras, and they're all using them on their project. So how do we get to laser scanning? So this is the roof of an air terminal in Hong Kong. It's a very complicated geometry. It's a skewed or off-grid geometry. The first thing you notice is that's the design model, that's the fabrication model. So you can see that as you go through the process, the level of detail increases dramatically. So the contractors' teams, the fabricators, add a lot more detail. On the underside of the roof is the ceiling system, and on the upper side of the roof is the rain screen and noise screen. So these are very complicated roof systems because of an airport environment, but essentially it's an aluminium cladding system sitting on top of a structural steel system. On the inside of the building, it's a clear span structure because it's an airport. All the mechanical system is inside the steelwork area. The ceiling system is hung from underneath. But what you'll notice from this image of the model is that the red lines are the primary structural steel, which are actually visible inside the airport. So when we were fabricating the steelwork, we had to make sure that these chords were 100% correct, or as close to 100% correct as possible. So when we installed the steelwork, the red lines became white because it was painted, because it was exposed. How do I check that that steelwork's in the right place? Traditionally, I would have to set up a whole bunch of scaffolding, then I would have to set up a survey team. They would have to mark out a grid on the steelwork at maybe 1 meter centers, and they would have to measure the datum along those centers, and then check that against the engineering calculations. This building was too complicated and too sophisticated, too busy to fill the whole thing out with scaffolding. So we tried to survey it with laser scanning. So a laser scanner is like a total station. So it basically, it surveys the steelwork using infrared light. And what it does is it creates a point cloud. So this is a 3D scan of the steelwork. This is the end wall of the building. And you can see the steelwork, you can see scaffolding systems, you can see the temporary work systems. You can capture all the details on the site. This has to be done by a surveyor, and it requires a very expensive piece of equipment. Once you have that point cloud, you can then bring that back to BIM and you can actually compare the two. And this is where the technology is immensely valuable. You can use the point cloud to validate the design. So the green is a scan from the site, the red is the engineering fabrication model, and you can see, now I picked the best example so we know that the steelwork was good, but you can see that the steelwork lines up with the engineering model. So we know that what's installed on the site matches what's on the fabrication models. We're good, we're happy. But what happens if we want to do something a bit more simple? What happens if we just want to survey steel brackets? So this is the prefabricated steel structure. So this was fabricated in China, delivered to Hong Kong. And we started to find problems with the quality of the work. And there was too many problems. So rather than surveying every single bracket, we scanned all these structures. So this is a point cloud scan of an entire link bridge. And it looks like the real world, right? So this looks like a reality mesh, a reality model, and you can see all the detail of the steelwork. The laser scanner is so precise and so accurate that we can take this point cloud data, again, check it against the steelwork, and we can start to quickly identify where holes are missing in plates, where plates are out of tolerance, for example, within the thickness of the plate, and we can pinpoint those problems. And then we can instruct the fabricator, you need to go back to here, 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 and here and fix it. This is a much faster way of surveying sites and steelwork. It's a much better way of doing interface checks, and it's highly accurate, 1 millimeter accuracy. The only problem is the hardware is expensive, and it needs to be done by qualified surveyors. This was 10 years ago. If you're not doing laser scanning now, I can guarantee you will be very soon. And what I want to show you next is where AI is going to take this technology. So when you combine artificial intelligence algorithms, point cloud data from a construction project, and a BIM model that's on the cloud, you end up with this. A technology called NASCA. NASCA is a European technology, and what they do is they highly automate finding the problems. So I'm going to play a video which explains the process, just to share with you where this technology is going to go.
We are capturing data on construction sites using devices like the BOK to go, which is really as easy as just walking around this device in your hand. You don't need costly surveyors to be able to capture all that information. Walk around, capture that high quality data, upload all of that to the cloud, and then what you have is raw data that our computer vision and machine learning algorithms then go to work on. We do recognize that we do not operate in a vacuum. We're not solving all your problems. We are just one portion of this ecosystem, and we're a platform that opens itself up to all of those inputs. So model data should live in ACC. Laser scan data, hey, that should come from Leica, that should come from Cyclone. We just take all the information that is already available, we process it, and then we deliver it back to you as an additional level of information. We're leveraging the investment that you have already made in these platforms and to gather all this information. So we take that and we turn it into actionable information that you can then use to make better decisions on. So we take every element in the BIM and we automatically classify it. So gray means no data, not enough information to make an assessment. Green is verified. That means it's within tolerance. That's obviously, it's good. Red is missing, so that means that it hasn't been installed. That's not necessarily a problem. That really depends on context. And then orange is out of tolerance and has not been built correctly. And then that lighter yellow color is under construction, which means that it's halfway between being built and not being built. This means that we can immediately flag up risks on your project. Here, there's a penetration, there's a block out, it's missing. I can immediately see that it is in fact actually missing. Here, lift shaft is telling me it's deviated, it's been flagged up. I can visualize that deviation in 2 seconds, and I can see that the lift shaft doors are the wrong size, they're missing material on the top. That's obviously a problem. Get out ahead of that. Here, this steel column, it's missing. That's obviously not great as we're moving the project forward. And in literally seconds, I can flag all those risks up to the guys on site who are then able to make better decisions with that information.
The reason I show you that video is to give you 2 messages. First of all, the technology is out there. So if you want to use AI for doing quality control, quality checking, it exists. But, and this is a huge but, if you do not have a good quality model that's detailed for construction fabrication, this technology is a complete waste of money, and it's not cheap. So you must have a very good quality of BIM and a very good level of detail to make valuable use of these technologies. And what we're seeing in industry is the contractors that started their journey in BIM, when I started my journey 15, 20 years ago, they get the value because they've been doing this for many, many years. What my objective here is, your roadmap at JKR should include, in a 5 to 10 year window, using these more advanced solutions. But you need to create a roadmap to get there in order to actually unlock these tools. So, rather than using the expensive laser scanning, There's an easier way to start this process, and it's called 360 cameras. A 360 camera is the same size as a mobile device, and it's got a lens on both sides. It's quite straightforward. This technology records a video. We recommend you do this every week, so you walk around a construction project every week. And for those of you who have seen this, the recommendation is that you walk around at the pace that you would bring your auntie if you were going for MACC. So you don't go running around the place, you walk around as if you're bringing auntie for MACC, and that's the speed that you walk at. So as you watch the engineer walking around, the 360 camera is on their helmet, and they have a mobile device. The mobile device is tracking their location, so the mobile device knows where they are, and the 360 camera is recording everything around them. So this is creating a video of the construction project in 360 degrees. If they stop, it will create a very high resolution photograph at that location. And in addition to being able to walk around with it on your helmet, you can also walk around with it on the stick. The advantage of the stick is you can put it up in confined spaces. You can put it up in ceiling spaces, etc., etc. I've done this and put it 10 meters up into MEP spaces. So this works at very, very long distances. When you're finished your survey, the software will then take your video, it will bring it to the cloud, and it will create a 3D model of your project based on your 360 photographs. And then you can compare your site to the model instantaneously. So in this example, there's actually a 360 video on a drone. This is an industrial facility. As you change either the model or the photograph, you can see what's happening in the other one. So as you're walking through this plant room, you can see the 360 imagery. You can also see the 3D model on the other side. So again, if you have a good 3D model, this is a very powerful way of managing a project. Where this is immensely useful is you can take objects from the model and you can copy them into the real world. So you can start to look at what happens if I install a pump, what happens if I install a new ceiling, what happens if I put a new staircase in this location, and you can visualize what the design will look like in the real world. The great thing with these 360 cameras, they're cheap, they're about $200 each, and the software is relatively cheap to run. So you don't need to have a surveyor, you don't need to have engineers, you need to have basically a mobile phone and a camera, and off you go. And you can use simple massing models, or you can use very complicated engineering models. So again, this is a very easy way to get a first tool to compare what's going on in the real world, what's happening in the virtual world. So going back to my timetable, my world changed in 2014. My son was born. He's now 10, so he now tells me what to do, so the chances of me telling him what to do are gone. He now bosses me around. We moved from Hong Kong to Malaysia in 2016, and I joined Gamuda. And I was very fortunate when I worked with Gamuda. I got to work on some amazing projects, including MRT2, including the high-speed rail. We also worked on the Penang LRT, and I did some work on projects in Australia. So working with Gamuda was an absolute pleasure. One of the things that we did in Gamuda was use drones for surveying. Now, most people have seen drones take photographs, take videos. But did you know you can do surveying with drones? And this is the only time you should use drones in a construction project, if you ask me. Drones are a very powerful way of collecting data, and they're a very powerful way of doing surveys. So how does a survey work with a drone? You take hundreds of overlapping photographs, 70% overlap, and then the computer converts these photographs into a 3D model that's accurate to about 20 millimeters. So depending on the elevation of the drone, depending on the detail of the photographs, you can create a 3D model of a project in about an hour. Okay? You can create a 3D model of a project in about an hour. It would take a survey team a month to do what I can do with a drone in an hour. So to give you a sense of resolution, that's myself and my friend Nick Moorcock standing by the excavator in that sample photograph. These were taken 9 years ago. And this is what it looks like in reality. You have an application, again, on a device. The drone is flying on its own. Nobody has to play with the joysticks. You tell the drone where to start, you tell it how many photographs you want, and it goes off and it flies over the site. A couple of golden rules. Always keep the drone in the site. Do not let the drone go outside the project. Because if it hits something like a telephone pole or a crane or another building, it's not going to end well. Okay, so keep the damn thing in the project. That's number one golden rule. This is one drone videoing another drone doing a survey, right? So this is just for fun, but this is what it looks like. The drone is just automatically flying around. If you get close to construction equipment, you have to be very, very careful. When we started doing this, we did have a couple of experiments, and in one experiment we hit a crane, and that was the end of the drone. So not recommended, they're not cheap. But you can use these for any type of civil engineering project. In order to make it successful, you need to have what we call ground control points. Again, the survey team need to be doing the drone survey. You need to train your surveyors to use drones. You do not need to buy a drone survey company. You just need to train the surveyors how to use the tool. This is basically a flying camera, and the surveyors love it. In Gamuda, we trained 25 surveyors to use these tools. So, get your ground control points, and then make sure you create a safety playbook. These are dangerous things. These are dangerous things. The battery alone weighs about a kilogram. If that thing falls out of the sky and hits somebody, it's going to be a serious injury. So we always operate with two people. We have a pilot who operates the drone, and we have a safety officer, we call them a spotter. And the spotter is basically watching everything else that's going around the project. And he has got a radio connection directly to the safety manager. So if anything happens, they bring the drone back and they land the drone. Okay? That could be a helicopter flying nearby. That could be a crane doing installation. It doesn't matter. Safety, safety, safety. Must be done. So I'm going to show you a couple of examples of what you use this thing for. Oops. If you're doing GIS, this is a great way to create orthomosaic photographs. These are true 90-degree projections. You can measure the width of the excavation. You can measure the area of the excavation. You can put this in GIS as an underlay, and away you go. For comparison, this is a Google Earth image, and when I overlay the orthographic, the buildings all go vertical, and you can see the actual projection of a tunnel through the actual urban environment. So the most basic use of these drones is to create ortho images that can be used in CAD, can be used in GIS, etc., etc. My favorite use is to use them for time-lapse. These are 3D models of the excavation for a station box for Bandar Malaysia, and you can see the advancement of the works over a month-by-month period. Because these are 3D models, I can measure volumes, I can measure depths, I can measure areas, and I can compare 1 month to the next month. Okay? Again, it took me 1 hour to fly the site on one occasion, and now I've got all this valuable data I can use over and over and over again. When you compare this, you can then use the model, and you can actually link it back to BIM. So again, if you've got a very good BIM process, you can use the drones to compare what's happening on the site to what's happening in the real world. So this is the excavation, this is the TBM arrival. This is what it looks like on the computer. So this is the mesh that's created from the photographs. This is a three-dimensional model created from photographs flown from a drone 100 meters off the ground. Okay? I can then overlay that with the BIM, so I can see what the diaphragm walls are, I can see what the slabs are, and I can get a sense of, okay, it's under control. Where this is useful is when you start to do monitoring every month. So you can start to monitor your progress. The yellow is the excavation limit, that's the base slab of the station, and you can see the progression of the project month by month by month. And I can use this to calculate volumes. How much material have I removed? How much material is left to be removed? Okay, so this is where drones are very, very valuable as a survey tool, particularly for civil engineering projects. And this is just a quick example of what this looks like in terms of quantity takeoff. So this is basically clicking on the boundaries, and in this example, I want to work out how much material do I need to remove to create a platform at a certain elevation. So I basically identify the boundary of the platform. So I don't have to pick the point, I just have to pick the outline boundary, and then I tell the software, please create an excavation, and I set my datum, I think it's at 30-something meters, 28.5 meters, and then it will give me the volume of how much material I need to remove to create that platform. Okay, so the software can actually do the calculation. So that's the use of drones. As we come to the end of the presentation, I'm just going to share with you one other technology, and then we're going to get to the questions. So in 2021, at the end of COVID, I went across to the Middle East, and I went to work on a project in Saudi Arabia. I was very fortunate to work on two projects. One was the Mala, and one was the Red Sea. These are incredible resorts that they're building. but Saudi Arabia was not for me, so I came back to Malaysia. And when I came back to Malaysia, I joined HSS engineers in KL, and we were working on MRT3. And as part of our work for MRT3, we started to put in place research as to how we were going to improve the actual work on the projects from a quality perspective. So I'm going to leave you with this last example of where I think this technology is going to go in the next couple of years. We are not going to look like this clown with a face mask. That's not how this is going to work, right? So you don't need to worry about having to put on this helmet with this big glasses. That's not what's going to happen. We're going to end up using mobile devices. But augmented reality is going to become a key part of our work. Being able to see the model in the real world. So everything I've shown you so far is taking the real world back to the office. This technology takes the office and brings it to the real construction project. And this is transformative. So the way this works, the model is in an iPad device. It can be a tablet, Samsung tablet, doesn't matter. And you can see what you're going to build in the future. So you can see what steelwork you have to install. You can see what bridge piers you need to erect. You can see what scaffolding is required. You can start to project what has to be built, which is a massively important part of construction. We started this process on the MRT2, and the apa Masalahnya was, how do I stop coring concrete? The problem that we have on most projects is that we build concrete structures knowing that in a year's time we're going to have to put a hole in the wall for a pipe, or we're going to have to diamond cut the wall to put a ductwork in it. But if we know where the ductwork's going to go, why don't we build it right the first time? So what we're doing here is we're actually bringing the models to the project so we can see where an opening is required. We can see where a pipe penetration is required. We can see where a sleeve is required. And we can make sure when we're checking the reinforcement that everything's in the right place. By using augmented reality, I can see what's going to be built in the future, so I can make sure what I'm building now is not going to cause a problem in the future. So this is what it looks like on the software screen. It's basically the 3D model in the real world. So how does it work? You have a reference point. So you start off with a reference point on your device. You then position that in your camera. So you identify where you are in the real world. And then you have now got the 3D model linked to the real world. So as you move your device around, you can see the model. There is a number of use cases for this. The first use case is quality control. So as you're doing an inspection on the job, if you're the inspecting engineer, you can make sure that everything that's in the model is installed correctly. So you can make sure the cable trays are right, you can make sure the pipes are right. If you see a problem, you can then document that problem. So you can take a snapshot of the model, and it will take a photograph of the real world, and then it will record that on your system. And that system can be Autodesk Construction Cloud, it can be Procore, it can be Bentley, it doesn't matter. But then you can assign that problem to someone to fix. So like the clash analysis, you find the problem, you identify that someone needs to fix it, and then you email them and say, hey, in this room, in this location, there's a problem. And then they go and fix it. So from a quality management perspective, this is very beneficial. So these tools are designed to work on the cloud. The good news is, even though we had SDEC talking about connectivity earlier, you don't need to have data on site. So you can do all this work remote. When you get back to the internet in your office, then it will all coordinate. So a couple of examples. You can use it to inspect pipework, cable trays. You can also use it to inspect existing buildings. So you can actually check plant rooms, you can check fan systems, you can use it to inspect existing facilities. And this will become a useful facility management tool. So then you can actually check the maintenance records, etc., based on these tools. So this is going to be a tool that we're going to see more and more frequently. This idea of bringing the model to the construction project and not the other way around. So that brings me to my current position at FTI. So you've seen my 20-year journey. I recently joined FTI. FTI is an American company, and we have over 8,000 staff. I work in the Singapore office, but I have a great opportunity with FTI. I live in Kuala Lumpur, but I spend 2 or 3 days in Singapore, but I spend my time traveling around. So I'm currently working on a few projects in Malaysia and a few projects in Singapore. We are an expert consultancy business where we provide advice. We have locations all around the world, which is probably not so relevant to Sarawak, but it's important to know the scale of the business. But what we provide is advice around digital disruption. And what I mean by digital disruption is everything from BIM, augmented reality, software, hardware, etc., etc. So a lot of questions can be answered, a lot of advice can be provided. But I'm going to leave you with just one example of how we can help you out. I've shown you a large number of different technologies, a large number of solutions. The problem is identifying which one. Okay? So being able to figure out which technology is going to solve a problem, which technology is the right one to solve, that's where I can help you out. So I can give you advice about what one's going to work, what one's not going to work, what process is going to work, what process is not going to work. But I want you to remember the same thing at the end of this problem. What is the problem? You need to define the problem first. Don't go away thinking, oh, Ronan's got this nailed, we're going to buy this technology and then we're going to solve problems. Start with a problem. Is it concrete construction? Is it openings in concrete walls? Is it ductwork installations? Is it surveying? What are the problems you're trying to fix? Then come up with a plan of attack. What are we actually going to do? How are we going to do it? What solutions we're going to need? And then you deploy it. So do a pilot study, make sure it works. And then the hard work really begins. Training everybody how to use these systems. So again, apa masalahnya? What's the problem? So thank you all very much for your attention. That is the end of the presentation.